Hey guys, today we're going to be talking about volume of three-dimensional figures. We are finally done with surface area. Volume is a lot easier to work through than surface area. So let's start off by talking about the Cavalier's principle. This principle states that if two solids have the same cross-sectional area at every level, then they have the same volume. So for example, if you have look at these two figures down here. Let me see if I can point that out. So if you look at these two figures down here, if you take this prism and you just slant it, that's not going to change the volume. It's still going to have the same volume because at each cross diagonal, it's going to have the same, not cross diagonal, cross sectional. It's going to have the same area. So like think about post-it notes, like a stack of post-it notes. Each post-it note has the same area, right? So whether you take the post-it notes, like the stack of post-it notes, and you slant them, it's still going to have the same volume because each post-it note has the same area, if that makes sense. Okay, so let's start off with volume. Volume of a prism, whether it is slanted, whether it's straight, it's going to be the same. Volume of a prism is going to be base times height. So the area of the base times the height. For the volume of a cylinder, it's still going to be base times height, but the base of a cylinder is going to be pi r squared, so it'll be pi r squared times the height. All right, let's do some practice. So for this first one, we have a triangular prism. We are asked to find the volume of this triangular prism. So we know volume equals base of the area of the base times the height. The base right here is a triangle. So I'm going to find the area of that triangle. Since it's a triangle, I know area of a triangle is 1/2 base times height, right? Little b. And then times my height of the entire prism, which is 5. Okay, so we have volume equals 1/2. The base of this triangle is going to be 3. The height of this triangle, which they were nice enough to give us, is 1.5. And then times my height of the entire prism is 5. So if I was to plug this into the calculator, I would end up with 11.25 centimeters cubed. These are cubic centimeters because now we have 3 dimensions. We have the length, width, and the height. So now let's look at this next one. This next one, once again, we're going to do volume equals base times height. Even though this is an oblique prism, doesn't matter. It's still going to be base times height. So let's start off by figuring out the base of this hexagon. Wait a second, they already gave it to us. That was nice of them. Usually we're not that nice. So we know that the base is 10 times the height, which they give us, is 4. So then we have that the volume is just going to be 40 cubic inches. That was really easy. Let's continue. So for this next part, we are given 2 different types of cylinders. One of them is going to be a right cylinder, and the other one is going to be an oblique cylinder. So let's start off by looking at this one. Now, for the volume of this cylinder, once again, we're going to do base times height. Volume equals base times height. So for a cylinder, the base of a cylinder is a circle, so it'll be pi r squared. So it'll be 2.5 squared pi times your height. So then, which in this case the height is 7, so it'll be V equals 2.5 squared pi times 7. So when you plug that into the calculator, you end up with 137.4 inches cubed. Alright, so for this next one, it's the same exact thing. Usually, a lot of times you'll be given this height, so like the slant height. You'll be given that height, and then you'll have to find the actual height. But for the sake of time, we've been actually given the height. So once again, volume equals base times height. The base is a circle, so it's going to be pi r squared. So it'll be pi times 2 squared, and then times my height, which is 11. When I plug this into the calculator, I end up with 138.2 centimeters cubed. All right, for questions 5 and 6, it asks us to find the missing dimension of the prism or the cylinder. This time they give us volume, and we are trying to find one of the following dimensions. So for this first one, we are trying to find the length, or the side y. So in order to do that, we know that the volume is 661.5, and then we know that it's going to be base times height, which in this case, base would be 18 times y, and then the height is 3.5. So that would be 18y times 3.5. So then I would end up with 661.5 equals 63y. So in order to solve for y, I'm just going to divide both sides by 63, and I end up with y equals 10.5 centimeters. And this time it's just centimeters because we're finding one of the dimensions. So let's look at this next one. It gives us that the volume is 75.36 inches cubed. And I know that this is a cylinder, so for the volume of a cylinder, I know that it's going to be pi r squared times my height, which in this case is 6. So it'll be p squared pi times 6. So then you're going to divide both sides by 6 pi. That's what I would start doing. I know some people like to divide both of them separately, but why would you do that? Anyways, so then you end up with P equals 75.36 over 6 pi. Remember, I'm going to keep everything in exact form until the very end. That should say P squared. Now, in order to get rid of the squared, you're going to take the positive square root on both sides. I know that normally you would take the plus and minus square root, but since we're dealing with distance, that makes no sense to take the negative. So just take the positive square root on both sides. You would get that P equals approximately, P is like 1.999, which is approximately going to be 2 inches. All right, so for this next part, it says, in exercises 7 and 8, describe how the changes affects the volume of the prism or the cylinder, multiplying the radius by 5. So first off, let's look at the old, and then let's look at the new. Okay, so for my old, I know that my old volume, it will be pi times 2 squared, so it'll be my base, which is pi r squared, and then times my height, which is 6. This will end up with 24 pi. If I was to multiply the radius by 5, then my new radius becomes 10. So it would be pi times 10 squared times 6. This would be 600 pi. Now, what happened? Well, let's see. If we do 600 pi divided by 24 pi, that ends up giving me 25. That means that my new figure is going to be 25 times greater than my old figure. So you could just say 25 times greater. Okay, for question 8, it says multiplying the length and width by 1/6. So I'm going to take the old, I'm going to do the old, and then I'm going to do the new once again. So for the old volume, it's going to be 18 times 12 times 3, which gives me 648 centimeters cubed. And then for my new would be 3 times 2 times 3, right? Because we're multiplying both the length and the width by 1/6. So then it's going to be, my new length is going to be 3, my new width is going to be 2, and my height remains 6 because it doesn't say anything about the height. So then when I do this, I end up with 18. So again, I'm going to do new over old, so it'll be 18. Forgot to put centimeters squared. So 18 over 648. When I plug that into the calculator, I end up getting 1 over 36. So then that means that it's going to be 1 over 36 times the original volume. Or you could even say that it's 36 times smaller because it is shrinking by a factor of 1 over 36.